In this video, I'm going to introduce you to loops. Now, loops are another kind of control structure along with conditional statements. So a conditional statement were those if, else statements, and those were types of control structures that decided whether or not to perform some action or some block of code. A loop structure instead is going to determine how many times we're going to execute some block of code. And so in this video, we're going to specifically talk about for loops, and we're going to use this example here of trying to control a servo motor again. So I still have my servo motor wired up the same way it's always been, 5 volts in ground, and then pin 2 over here for the control wire. And if I go back over to my program here, what I have is just the very basic setup where I'm configured the serial port, I've attached the servo to pin 2, wrote it to some initial position of 0, where then I wait for 2 seconds before it continues on to the loop. And what it does inside of the loop is it goes to 180, waits for 1 second, then goes to 0, then waits for 1 second, then it goes back up to the top of the loop and runs over and over and over again. All right, so we're going to take a look at this and just make sure that it works the way that we're expecting here. So I've uploaded that program. It's taken a second here to upload. And then we should start to see it go from 0 to 180 and 0 to 180 over and over again. And there it goes. So it's going from our 0 to our 180 position and back and forth. So I'm going to just temporarily unplug this so that it stops sending that control signal and moving. But if we look here, what happens is every time that you tell the servo to go to some position by saying right that position, it is sending the signal on that control wire to tell it to go as fast as it possibly can to that position. It's just trying to race to get there. But maybe we want to better control the speed at which it is moving from one position to the other. Say it's attached to some armature, and if it moves too fast, it could break it, or we just want a more fluid movement from one position to another. So we took a look at how to do that before using a global variable, but sometimes we might want to do that using our own loop structure where we can control that. And so these loop control structures are different from this function called loop, and we're going to take a look at one type of a loop structure here. And so the first one we're going to take a look at here is a for loop. And so a for loop looks something like this, somewhat similar to our if statement, where we had if, and then we had some stuff inside of the parentheses here, and then we had our curly brackets denoting what is a part of the if statement. Our for loop is going to perform in the same way, where we have the word for, and then we're going to have some stuff inside of the parentheses, and then the code that is in between these curly braces is going to repeat over and over and over again based on some certain condition. So for our for loop, there are going to be 3 statements inside of here, as opposed to our if statement, which just had one single condition inside of there. There are 3 pieces inside of here. And so I'm just going to write the names for them, and then we're going to fill in the code that makes sense for that. So the first one is the initialization. So this is something that is going to initialize and set up our for loop. The second statement inside of here is our condition. And so these are each going to be separated by a semicolon. And then the last one here is the update. And so we're going to break apart each part of this and kind of show how it operates. So the initialization is just a statement or a single line of code that is going to execute once before the for loop runs, and then it's done. It just executes once right at the very beginning. The condition is something that is going to be checked every time right before the loop executes. And if this condition is true, it will continue to execute that for loop. Once that condition is false, it will stop to execute the for loop. And what I mean by execute is go back through and perform all of the code that is in between these curly braces here. So while this condition is true, it's going to run over and over and over again. And then once it's no longer true, it will stop and go on to whatever else is left in the program. Then we have this update here. And this is the very last step. And what is going to be here is a statement that talks about how we are going to update something after the loop executes. So it'll make more sense once I actually start to put in some code here. So what we're going to do is we're going to use this structure to control the angle of our servo and have it in each iteration through the loop body, write it to some new angle and then wait for a little bit so that we can kind of increase it by 1 degree each time and fine tune and control the delay to make it move faster or slower between those different angles from some start position to some end position here. Okay, so what I'm going to do is for my initialization, I'm going to declare a new variable for this. And what I will do is I will declare some variable called int, or a variable that is an integer variable, and the name of it is just going to be angle, because that's what it's going to represent. It's going to be the angle that our servo is going to be at, and then I need to initialize that value. All right, so I'm going to initialize this to 0. That's going to be the first angle that we're going to write it to. Then what I need to do here for the condition is determine under what condition I want my for loop to continue to run. And so what I'm going to do is I'm going to make this do pretty much the same thing that we were just doing here with these lines of code. I'm going to want it to go from 0 to 180 and then from 180 back down to 0. So we're going to do that with 2 different for loops. So my first for loop is going to go from 0 to 180. So I'm going to write this comment here just to kind of describe what's going on. So my angle is going to be some value that starts at 0. And what I'm going to want to do is continue my for loop while that angle is less than or equal to 180. So this is my condition here. And maybe I should have left a comment here kind of describing what each part of this is. So let me add that back. So initialization, and then we have our condition, and then we have our update. So those are the 3 parts of our for loop. So this is our initialization, where we're initializing some variable that is sometimes called a control variable because it is controlling our for loop and determining how many times it's going to execute. Basically, it's going to execute for every value of angle between 0 all the way up to and including 180. And then this last part here is the update. This is going to determine how we are going to update this control variable here. And so what I'm going to do is I'm going to write angle plus plus. And so what angle plus plus means is just add 1 to the previous value of angle. It is a shorthand for me saying angle equals angle plus 1. So I'm just going to write it in this shorthand way because it's a little bit more succinct. It's less typing on the keyboard. And that's it. Those are our three statements that make up this for loop. So what happens is when our program reaches a for loop, it's first going to perform this line, which declares a integer variable called angle and sets it equal to 0. In the initialization block, that is just performed once, this initialization statement. Then what happens is it goes to this condition and it says, okay, is this condition true? Is our angle less than or equal to 180? If it is, it's going to enter inside of this loop and perform all of the code inside of here. Once the code inside of here is done, what happens is it comes back up to the update block and it performs this. So it will update that value by adding 1 to it, and then it goes back and it checks the condition again. If that condition is still true, it will then go back inside of the loop, perform those steps, and just repeat this over and over again. So to showcase how this works, I'm going to comment this out temporarily, and all I'm going to do is say serial.println angle to just print that value of angle to make sure that we understand what's going on here. So let me upload this program, and I'm going to then open the serial monitor so that we can see it. So here we are. Here's our serial monitor. And so we can see it's printing very, very fast here because there's no delay, but it's going from 0 up to 180 and then 0 to 180 in steps of 1. Because what happens is it starts at this value of 0. It says, okay, angle, which is equal to 0, is less than or equal to 180. So then it prints that value 0. Then it comes up here and it adds 1 to that value. So angle becomes 1. Then it checks the condition and says, okay, is angle less than or equal to 180? So 1 is less than or equal to 180. So it comes back in, it performs this step right here, and it prints the angle value of 1. And then it goes here and it adds 1 to angle, so it becomes 2. And it keeps doing this process of checking the condition, performing the code inside of the for loop, performing the update, and then checking the condition, performing the code inside the for loop, performing the update over and over and over again until we get to here where we print 180. Then we go here and we add 1 to 180. So it becomes 181. And then it asks, okay, is angle less than or equal to 180, where angle is 181? And that is no longer the case. So this condition here is false. It will not print a value of 181. It will then end this for loop. And so this for loop stops. And then that just happens to be the only thing inside of loop. So it goes back up to the top and then runs through this again. So it is weird that we have this for loop inside of some function that just loops over and over again, but that's what's going on here. And so to kind of better showcase what is happening, what I'm going to do is instead of we can continue to print the value, but let's actually move the servo to the position determined by angle. So that's my servo.right angle. And then let's add a little bit of a delay here. So I'm going to say delay for like 20 milliseconds. So this will delay 20 seconds between each angle as it goes in steps of 1. So it'll go, 0, 1, 2, 3, 4, 5, all the way up to 180. And then this loop will be over. So then what I could do is, just to make sure that we understand what's going on here, is let's copy this. And let's create another for loop here, but instead of going from 0 to 180, because at the end of this loop it is all the way at 180, let's go from 180 down to 0. And so for this, what I'm going to do is I'm still going to have this for loop here that starts some variable, an integer variable of angle, but it should declare it now to be the initial position that we want it to start at. And so we're saying that we're going to start at 180 and go down to 0. So I'm going to say the initial value of angle should be 180. And we're going to want to continue this until we get down below 0. So our condition here should be while angle is greater than or equal to 0, keep doing this over and over and over again. And then there is this last step that we need to do. Because if I started at 180 and I added 1 to it every time, it would keep going up. It would go 180, 181, 182, and it would go over and over and over again, which would mean that angle would always increase in size and it would never become less than 0, which is when this loop would stop. And if that's the case, we have hit an infinite loop. And what that means is that this loop will run infinitely and it will never stop, and our Arduino will never get to any other code. It will just stay there forever, and that's not what we want. An infinite loop is a common programming error where we're not exactly, where we're probably not checking the correct condition. All right, so that's something that we want to look out for. So what we want to do is, instead of incrementing angle or adding 1 to angle, which is what we did right here, what we want to do is subtract 1 from angle so that it goes down from 180 to 0. So the way of doing that is angle minus minus, which is the same as saying angle equals angle minus 1. It's just a shorthand for that, so I will put that there. And so what we should see is when I upload this program, it should go 1 degree at a time from 0 to 180 with a 20 millisecond delay in between each degree. And then it goes from 180 down to 0 with a 20 millisecond delay in there. So let's upload this and we'll pull up the camera so that we can see what we've got going on. And we can also pull up the serial monitor here just to see what we got. And there, we start to see it move from 0 up to 180, and then 180 down to 0, and then 0 up to 180, and then back down again. So we are now more carefully controlling the speed by saying what is the delay we want between every single angle. So if I want it to move a little bit slower, I could just up these delay values from 20 to 50. And say, wait 50 milliseconds between each of my different ones. So it's now uploading, and that was the initial very fast movement to get it back to 0. And so now it's going up to 180. We can see these numbers go up slower. And then once it hits 180, it should go back down. And there we go, now it's going back down. So by using a for loop, we are dictating what we want the motor to do specifically. We're saying we want it to start at 0, and go up to 180 in steps of 1, and write each one of those individual positions moving degree by degree and controlling the delay between each of those. Now I could change these. If I only wanted it to move 90 degrees, right, I could say, okay, start my position at 0 and go up until and including 90. And then for this one, I could change this from 90 to go back down to 0. You're able to really carefully control what you want the servo to do with something like this, as opposed to how it was before, where it was just moving as quickly as it could from one position to the next. So a for loop is a really good candidate for this, because we create this control variable where we're saying start at this value, end at this value, go from this value to this value by adding 1 to it. Or down here we're saying start at this value, go down to this value, and subtract 1 each time to go there. And then we're saying the steps that should be performed in these curly brackets here every time the loop executes. So this would execute like 181 different times for every angle from 0 all the way up to and including 180, and then this one would also execute 181 times for the reverse.